Monomials. Today we're focusing on just monomials, single terms, and we're going to be multiplying them. Now, what we're going to be working on here is a lot of exponent rules. When you are working with exponents, because that's what we're going to see here, multiplying monomials could be as simple as 3 times 2. But of course, that wouldn't be 8th grade algebra. So what we're going to see is a lot of exponents. So one of the rules when we work with exponents, and I'm not sure why, but the standard pattern in math is that, because we're going to have all sorts of different exponent rules here, the standard pattern is we use A for the base number and M and N for the exponents. You'll see this again later. I don't know who decided on these letters, but that's what we use. So that's what I'll be using. When you multiply the same base number, if you're multiplying numbers and they have exponents, if they have the same base, you are going to add the exponents. That's the rule. I'll show you a couple of examples. And I think that's the only one we're focusing on today. Let me see. Yes, tomorrow we're going to focus on a different exponent rule. So I'll give you a new rule tomorrow. Let's start with this one. Let's start simple. Let's say we don't know the base, but I know it's the same because it's the same letter. What would I get according to that rule? What is x cubed times x to the 5th going to equal? Jaden?
X 3 plus 5.
Okay, and we can just go ahead and do that. You could write the 3 plus 5, or you could just do it in your head and say 8. If you want to write 3 plus 5 first, you totally are welcome to. But the most important part is that final answer of 8. X to the, and really, you guys, you don't need to do this. You can write this down if you want. This is optional. Let me just show you why this works. X cubed is x times itself 3 times, right? That's all multiplication. Bless you. Then we times that by x to the 5th, which is x times itself 5 times. It's all being multiplied. The x cubed is x being multiplied, the x to the 5th is x being multiplied, and I'm multiplying those two things. So really all I'm doing is adding up all of those. This is x to itself how many times. I combine them all to get to 8. Now that one's pretty simple. So let's go a little bit harder. What if I had b to the 7th times b to the -4th? We haven't gotten to negative exponents yet, but we will. And of course there's one right here. What would I end up with according to this pattern or exponent rule? Brian? 7 plus -4? 3. Later on I'll be showing you what happens if you get a negative exponent in your answer. There's a way to simplify that, but we're not getting to that yet. Okay, let's do another one. Let's make it harder. Here's a monomial, 3n squared. That's one term. Right, it's all one. If it's a binomial or a trinomial, it's going to have pluses and minuses in between the terms. So this is a monomial, even though it has a little more going on, times another monomial. So I'm just showing you sometimes your book will use parentheses to show the two monomials. Sometimes you'll just use the dot, but sometimes you'll see parentheses. Either way, today it's all the same. It's all multiplying. Now again, you don't have to write this in your homework, but let me show you how we're going to do this. This is 3 times n squared times 4, which is times n to the 4th. All of those pieces are being multiplied. You don't have to break it apart like this in your homework, but you need to be able to think about it this way, because what we're going to do is, technically we're using the commutative property, and we're putting them in a new order. You don't have to write that new order if you don't want to, but as long as you can think, oh, I would reorganize and I'd do the 3 times 4, which makes 12. And then I could do the n squared times n to the 4th. Right now, again, these aren't like terms, but if we were going to use the commutative property to reorder it, we could put all those things that are alike, plain numbers, n's, same base number, we could move them together. And really what you're going to do is you're just going to multiply those things that you can multiply. 3 times 4, I can multiply those and simplify it down to 12. If I look at these next to each other, maybe it's easier, but otherwise you can just look at the original problem. If I multiply the same base, I add the exponents. 2 plus 4 is 6. So if you can get straight to the answer just by looking at it, then what I've underlined here is all you need to show. If you think you need to break it apart to understand what you can multiply to make it simpler, then you can write it down like this. So that's going to be up to you, what you think you need. Okay, let's do just one more, I think. Let's make it a little harder still. Last one. Negative 3a cubed b squared. There's one monomial, right? So how does it get harder? Well, the monomials get bigger. This is just one term, even though there's so much going on. Times a second monomial, 5ab to the fourth. Two big old monomials being multiplied. All right, you could write it all separately. You could, if you wanted, write negative 3 times a cubed times b squared times 5 times a times b to the fourth. But if you don't want to do that, you don't think you need to, tell me now, which things should I start multiplying? And remember the kind of the pattern of what goes first. Let's start with that first. Daniel.
Negative 3 and 5.
Good. Negative 3 times 5. We always want to put the number first before the variables, so I'd suggest start with that. Don't forget negative times positive makes a negative. Okay, what would come next in the order we want our answer to be? CJ.
A cubed times 3.
Okay, good. When we have the same base being multiplied, because this is all being multiplied, we add the exponents. CJ, what's the exponent on this A?
1.
Just 1. Like the invisible coefficient of 1 that could go in front, we also don't show the exponent. We can tell it's 1 because there's only 1. 3 plus 1, a to the fourth. Finally, our b's. What exponent will I have? I have b squared times b to the fourth. Leanna?
6.
Good. We add the exponents. There's our answer. So today it's just going carefully and slowly, watching for negatives, keeping an eye on all of your exponents and all of the variables, and making sure that you go slowly and carefully. Today, I'm not going to ask you to do evens, I'm going to ask you to do all. So just go carefully. 1 to 18, all. So that's just going to be a habit you got to break. We've been doing evens for a long time now. This time you're doing all of them. It sounds like a lot, guys, but the first, like 4, you're going to whip through in like 10 seconds. They're very simple. So I think you guys should be able to finish this by lunch still. I'll be coming around and checking in on you for tutoring